Okay, so I would like to talk about short-term recognition of timbre. Again, looking at perceptual familiarity, although at a slightly different angle on it, more towards sound source categories. And I always like to start with some sort of brief listening exercise. So you just listened to the first 20 seconds of one version of John Zorn's piece Cobra, and I can assure you it gets better every time you re-listen. So my question that I'm trying to get at in this talk today is what's happening when we listen to this kind of stimulus? Perhaps intuitively, one way of putting it would be to say our faculty of short-term memory, which is of course foundational for the construction of some sort of event structure of the immediate past, must somehow be overloaded with information, and that's why this might be so funny and also so disturbing to listen to. Another thing that may have stood out here is that some timbres are easier to keep in mind. At least for me, the piano is quite easy. This chord, it's quite salient to me. While others, especially the weird ones, cannot really be categorized quickly and therefore might be lost faster. So in my PhD, I studied various factors that affect short-term recognition of timbre, and today I just focus on the familiarity part. And I find familiarity particularly interesting because timbre is often seen as some sort of surface feature that from a musical point, one could say resides in the moment, something like auditory makeup, to make it extreme. I think this whole workshop refutes this hypothesis, but still if we could provide evidence that long-term experience with timbre shapes short-term processing, this would of course have implications for this common stance. And one undercurrent of this theme, since we borrow many of our methods from verbal memory research, is the extent to which music and language processing share similarities. Both projects have some sort of implications for this. So the first one is comparing the recognition of recorded versus transformed sounds. One could also say chimeric sounds. It was actually inspired by your work on transformations. And the second part is then looking at North Indian tabla, which is a really nice fusion of language and instrumental music. Okay, so the first project considers the question whether familiar acoustic tones are better held in short-term memory compared to unfamiliar abstract transformations. The tentative visual analogy would be to compare this Van Gogh, for example, which gives rise to the association of a lake, for example, with a completely abstract Pollock, which is at first sight really just a bunch of colors. There's also the analogy in language, where we know from the lexicality effect that short-term memory is better for words than compared to pseudo words, so which respect the phonotactic constraints of the language, but are meaningless and not part of the dictionary. So to get at this question, we used unfamiliar sounds that were of similar acoustic complexity as the recorded instrumental tones that we used, and this question of acoustic complexity is important because it has been shown that this plays into short-term recognition as well. So we decomposed them into 24 gamma tone filter bands, and then for each band extracted slowly varying amplitude envelope as well as the temporal sign structure. And then we mismatched these two components and summed across all filter bands and derived a new transformed sound. And we, in this way, we generated a whole bunch of unfamiliar sounds and had subjects rate them on familiarity, and then we selected the 14 least familiar transformations. And together with the 14 recordings that we used, they were matched in loudness. And then we had people rate the dissimilarity of those tones, pairwise dissimilarity, in 3 sets: recordings, transformations, and a mixed set. And this is important for controlling perceptual similarity relations within the memory set. Okay, so this is kind of the initial work, and now comes the memory. So these were the recordings. So we then presented 3 tones, which could either be recordings or transformations, followed by a delay and a probe. And the question then was whether the probe was part of the sequence or not, so standard item recognition paradigm. So here's an example. Yes or no? Oh, well, I think it's always very hard in the beginning. But that's right, it was old. It was second position in the list. And our subjects, 13 musicians, were not too bad in this task as well. So we obtained the main effect of material and of delay, but no interaction between the two. And we also observed that for new probes, the mean list probe dissimilarity correlated significantly with the listener's response choices for both recordings and transformations. And the initial question then, of course, is why is there this advantage for familiar sounds? Could it be that familiar sounds are simply labeled and then retained via verbal rehearsal, so kind of outsourcing auditory memory towards the verbal domain? So we wanted to get at this question, and thus used classic interference paradigm. So we here compared the silent control interval of 6 seconds with a visual suppression condition, which is attention demanding. So people saw these types of grids, 4 by 4, and then they had to detect immediate repetitions before answering to the auditory question. And then we also had this classic articulatory suppression condition where subjects were supposed to count aloud during the retention interval. So this is how this should sound. You heard the musicians on the left and the non-musicians on the right. So the idea is, of course, if sensory persistence alone as a maintenance mechanism was the dominant factor, then visual suppression should not have an effect because it doesn't interfere with the auditory trace. And if verbal labeling was dominant, then articulatory suppression, but not visual suppression, should have a strong effect. Okay, so here are results. We obtained main effects of musical training and material. And there also was a main effect of suppression, where we found that both musicians and non-musicians were better in the silent condition than in the 2 dual task conditions. So in a sense, the counting condition here does 2 things. It interferes with the auditory trace, as I said, and it interferes with our resources for verbal labeling as well. But then counting decreased sensitivity only for the counting decreased sensitivity with similar margins for the easily labeled recordings and the not so easily labeled transformations, which we interpreted as evidence for that the auditory trace is responsible for this effect here, so for this detrimental effect of the counting condition. And then the effect of visual suppression suggests that it's not mere sensory persistence, which is often thought of as independent of attention. So this means both attention and the fidelity of the auditory trace seems to be important, and the conclusion would then be that subjects keep the memory trace intact by simply paying attention to it, which is called attentional refreshing in the literature. So it's not simple labeling, as some authors have proposed. It's kind of a more attention-based, versatile maintenance mechanism. So this is also reflected in post-experimental questions that we gave our subjects. So you can see here on the left-hand side the musicians, on the right-hand side for the second experiment the non-musicians. And the first strategy, I don't know whether you can read it well, was imitating sounds in my head, and, which would be the analogous version of attentional refreshing. And then, interestingly, they also list a variety of other strategies, especially the musicians, which really suggests that short-term memory for timbre shouldn't be seen as a mere echo in the mind of the listener, as some authors have suggested, but really more as a flexible kind of workspace that revolves around sensory representations, but also trades with the plurality of other, so to say, mental currencies. Okay, so I would also like to briefly mention this second project on North Indian tabla. But before I say a single word, here's our collaborator, Sean Marvetsky, introducing the issue.
The tabla is a pair of drums from North India. It's the most common, the most popular percussion instrument from that part of the world. How we learn tabla is through this vocal language called bull, which is a lot like solfege. So as a melodic singer in the West might sing do, re, mi, fa, sol, on tabla we have these vocalizations, these bulls, for every sound that we play. For example, na, din, tun, te, ke, and ge. Then if we have combination sounds, of course we need new bulls, because I can't possibly speak two sounds at the same time. So for example, na and ge gives dha. Tin and ge, pin. Te and ge, de. And then, just like letters of an alphabet, we can start to put these bowls together to create words. For example, tire kita, kita taka, tire kita taka, dha tire kita taka. Then once you know some words, you can start to make phrases. Dha tire kita taka, tak tire kita taka, dha tire kita taka, tin na kita taka. And so on.
I continue to be excited by this video. It was the first shot. I just asked him, hey, tell me a little bit about tabla, and he went for it. So the basic question that motivated our study then was, of course, whether there's an underlying cognitive principle for this fact that verbalizations are being used in tabla learning and teaching. So perhaps they might be simply easy to memorize. Trevor discussed this kind of voice superiority effect. So in our experiment, we compared drum strokes on the tabla with their corresponding bowls, and then measured performance of both tabla students and musicians naive to tabla. And we used a serial recognition paradigm. So you would hear 8 items, followed by a break, and 8 items again. And as Sean illustrated, tabla sequences are highly structured, and one important part of the structure is hierarchical ordering, which arises through the nested repetition of chunks. Both are kind of hierarchical structure. And in this experiment, we try to decompose the structure with a sequencing factor that comprises 4 different types of sequences. So here's an idiomatic sequence that are familiar to people familiar with tabla. And here's an example of this. subject had to say whether it was same or different, and I assume all of you knew it was different. So some of them are quite easy. Reversed sequences are idiomatic sequences that are simply played in reverse order, which retains all aspects of sequential structure, but removes the sequential familiarity for people who are familiar with tabla. And then random order sequences comprise the same items as idiomatic or reverse sequences, so also have the same item redundancy, obviously, but have simply a random order. So there are still affordances for chunking based on repetition of items, but there's no hierarchical structure anymore whatsoever. And then, as a control, there's a random item condition, where every item is presented only once, which removes any sort of redundancy and structure. So here's a random item trial with bowls.
Na, ka, ki, te, ha, ka, ti, re. Na, ka, ki, te, ha, ka, ti, re.
And this time it was the same. And here are our results. So contrary to our hypotheses, we did not obtain an effective material. So there was no global difference between recognition of bowls and tabla strokes, and also tabla students didn't do better than musicians in a global sense. However, there was a strong effect of sequencing, as you can see. So if you go from left to right, if you remove structure, performance gets worse. And this, of course, speaks for the hypothesis that listeners strongly exploit this structure by chunking these sequences into smaller units. And then we further obtained two-way interactions, which seem to be driven, however, by the three-way interaction of sequencing, material, and group. So here we found that only the tabla players, only in the idiomatic conditions, were better for the bowls compared to the strokes, which is somewhat surprising, but then again, it gives plausibility to the century-old pedagogical tradition, which uses bowls as an aid to memory, as an aid for the teacher to transfer a tune basically to the student, because there seems to be superior mnemonic properties for this kind of stimulus. Okay, so I'd like to conclude with some global perspectives. It seems, at least it was my personal conclusion, once you start thinking about something seemingly basic as short-term recognition, you're suddenly in the midst of auditory cognition and really can't get around the notions of representation, categorization, chunking, hierarchical processing anymore. And in a way, this of course parallels the parameter of timbre itself, which is really not easy to separate in a meaningful way from pitch, loudness, reverberation, musical context, etc. So to bring these somewhat holistic ideas to a close, I would like to propose a rewriting of a cherished closing statement of Reihe and Wessel, which in my version reads as follows. So everything in blue is replaced and new. So the role of memory has extended to that of central subject of music cognition. Then paradoxically, the very notion of memory, this catch-all, multidimensional attribute with a poorly defined identity, gets blurred, diffused, and vanishes into the musical mind itself. Thank you.
Coming back on that last data on the tablet layers and the different groups, I'm a bit surprised that, like you were, I guess, that they increased the memory ability for bowls, but not for tabla. Does that mean that even for tablet layers, they don't hear the bowls in the tablet sound sequences?
Yeah, that's a good question. I mean, they could, of course, so to say, translate or extract the bowls from the sound material or from the strokes. but apparently they do not. And I would interpret this in the sense that once they are given such a short-term memory task, they perhaps just go with the most intuitive strategy, which is to perhaps theoretically compare these two chunks, or these two 8-item sequences.
Training too.
Sorry?
A little training is out there.
Yeah, surprisingly, it doesn't have an effect. So we didn't see any sort of correlation of the month of tabla learning on their sensitivity, which might be also due to other issues, but at least if we take that serious, it would suggest that this sort of advantage that arises for the bowls happens really quickly. So as soon as they had their 11 months of tabla playing, which was the baseline for being included here at the tabla play, they were already had set up this special type of processing for the bowls. And it might be just mere vocabulary learning, right? We're very good at chunking verbal material together, especially in German. Langfarbenmelodie, right? You can just immediately chunk and you integrate it to a higher level. So
they're still good enough to know the idioms, right? I mean, they're better in the idiomatic conditioning rules than in the rulers, so they know they're solfaing, basically. Interesting.
So your sequence of notes were very slow compared to the video that we saw. Do you think you would have seen a great, at least significant differences if your sequence was much faster than the video?
yeah, you never know with memory, because if you tweak one parameter, you may be able to screw up everything. So I would say this type of this speed is fair. Of course, if you listen to a proficient tabla player, then it's much faster. But at least this speed would be a speed that is common in tabla pedagogy. So if your teacher teaches you a new tune and you're kind of at that level of experience as our tabla player were, they were not proficient or professional tabla players, but only beginners actually. Then this is, I think, fair. I can't really say how it would otherwise affect the results.
Hey, I have a question about the first part. I was wondering what kind of processing you applied. Was it cross synthesis? So you take the spectral envelope from one sound and apply it?
Yeah, it's the standard method that originated, as far as I know, from this Smith and Oxenham 2002 paper, where you take the temporal time structure of one sound and apply the temporal envelope, spectrotemporal envelope to it.
Yep.
I'm not sure if this is relevant to your study at all, but I've studied tabla, and after a few months, it was kind of awkward in the beginning, but after a few months I found that the technique of reciting the bowls, this was something that I had to do to remember to play pieces, more than muscle memory or just saying the piece with the bowls. And as far as to the point about the tempo, you learn the pieces in different tempi, so you learn just to do it slowly and to do it quickly as well.
So that actually relates to this question of distinguishing the effect of the acoustic and the verbal. So if you were to play a faster presentation rate, probably, in fact, it's difficult to speculate whether the recognition of the pulse could be effective, because the rhythm at which the sound, the vocal cues are presented seems to be more sort of speech-like overall, and that
right,
can actually get you into a different mode.
Yeah.
I have one question. Were you Canadian or Indian?
They were Canadian musicians, and all of them were students of our guru, Sean.
Is
because when you hear the voice, it sounds, at least like in other France, it doesn't sound that phonemes and vowels that we have in the language, so maybe there's also top-down language there. And if you're used to hear this vowel since you are born, maybe then you don't need as much to rehearse this book in your head to learn the...
That's actually an interesting comment, because we could, I mean, the consequence would be to do this experiment with non-tabla playing Hindi, I guess.
Yes.
And then when we see the same effect, then it would be much better to vocalize again.
Yeah. Any other